I'd just like to buzz through now and introduce Neil. Dr. Neil Thompson is one of the people we sort of stumbled across early as we explored energy. And he is, like Charles, able to continuously sort of stretch the brain and expand the possibilities. So as we're standing around here on the top of our mountains today, being guided, Neil is going to show us the Valley of Hydrogen and its potential. So over to you, Neil.
Thanks for that introduction, Jock. And yes, I'm sitting up here in dairy country in Mullaney, so I hope the internet holds out, everyone. But thank you for that. Can you see the screen okay?
Yeah, all good.
Yep.
Yep, all good. Cool. All right, and also thanks to Charles, because that was a great segue. And I guess that's one of the things we always say up front is that this is not VHS versus Beta, particularly on farm. You know, any mobility applications, tractors, quad bikes, etc. They're electric vehicles. It's just that in the case of some of the heavy equipment, it's got a tank of hydrogen running a fuel cell to create electricity for the motors. So, good question earlier about looking after those things from a mechanics viewpoint. Yeah, a lot less to go wrong with electric motors than diesel. So I don't envisage a big upskilling in electrical skills on farm. But just to kick it off, I mean, there's a lot happening, I guess, in the hydrogen space around Australia. I always encourage people to have a quick read of the CSIRO National Hydrogen Roadmap on the left-hand side. That was launched back in 2018. And then subsequently, Dr. Finkel, who Charles referred to, launched the roadmap through the Council of Australian Governments. So that's all the states and territories getting together with a consolidated view on where we head as a nation with hydrogen. And Finkel makes the point quite often that you know, this is one of the rare subjects of hydrogen that all the states and territories have a bipartisan view on. So it's great to see a national response that's matched by state and territory intent. And I guess a plug to Jock and Mike and the team that New South Wales is leading the charge, I must say, in terms of getting on with the job, particularly in agribusiness. Just a quick view around the country. Certainly the federal government's made money available to a big project up here in Queensland, up in the Daintree. Hard-nosed economics in terms of getting more reliable electricity. Most of the folk up in the Daintree are running off diesel jennies. So if we have floods and you can't get diesel, you've got no power. So loss of income both in agribusiness and tourism. So a big project up there now going off grid. So solar, wastewater, and hydrogen to run generators for the agribusiness and also for tourism. So that's real. That's now, and there's certainly money available for larger schemes for communities to go off grid to hydrogen. One closer to home is basically the New South Wales transport. There was a call yesterday, I think the former minister, or shortly to be former minister, Constance, made the call that all 8,000 public transport buses in New South Wales will go to zero emissions, and that will be a mix of battery electric buses and fuel cell electric hydrogen buses. So certainly we're working on a program now to have this rolling out over the next 2 years. So once you're in the city and regions, you'll start seeing some interesting stuff happening on the roads with public transport. So that's great to see. So I'm trying to get this. Okay. At the big end of town, certainly, you know, a big country like Australia, one of our challenges in diesel, particularly in regional Australia, is that cost effectiveness of diesel for transport. I think it was touched on earlier about you know, the tyranny of distance. So one of the problems we have in terms of our carbon accreditation for agricultural products is the high carbon miles from transport. So one of the things we're working on currently is with the major prime mover manufacturers. And now we've had an announcement in WA that Hyzon has decided to set up shop in WA. And also, not to be outdone, a group of management team ex-Hyzon are actually setting up in Port Kembla. So bring it on, but yeah, lots of competition in the heavy trucking sector, which will have a ripple effect in terms of reducing our carbon mile intensity on our agricultural produce to market internationally. And as I think it was touched on earlier, certainly our European customers are very keen to see the carbon mileage and intensity of our farm produce. So these trucks will certainly help to improve that competitive advantage here in Australia around hydrogen, renewable hydrogen usage. Pleased to say that ARENA, the Federal Renewable Energy Funding Agency, had a call for $70 million worth of funding for hydrogen projects. That would generally pay for about 2 or 3. The program was oversubscribed with about 36 projects going up for around $3 billion in project value. So it certainly goes to show that again, the topic of hydrogen is very much advanced at the industrial scale, and lots of announcements probably late July, early August in terms of some of the projects you'll start seeing being rolled out through that particular ARENA fund. So lots of money around, and the last but not least, BP, a household name on farm, and basically setting up a feasibility study at Geraldton, look at using water Geraldton for production of large-scale hydrogen and ammonia. And again, that's just part of their overall plan. So again, when we start seeing major fuel retailers such as BP announcing publicly a transition to hydrogen fuel and ammonia, you'll start to see this impact on farm in terms of wholesale fuel distribution around the country. What we do basically is making that white box in the middle. It turns renewable energy, supply, wind, even coming from biogas, and wastewater predominantly into hydrogen and oxygen. We generally do 3 things with the hydrogen. Charles touched on the fact that we can inject that into a gas network and start decarbonising our gas networks and control gas pricing, which is a big problem here in Australia for industrial customers. We can use it as clean fuel on farm and in the cities, as I talked about, for the buses and also tractors. And thirdly, use it as a feedstock, such as BP's Geraldton project, to turn renewable hydrogen into renewable ammonia for export and production of fertiliser, which comes back to farm. ITM itself, I first met them back to 2009 in the UK. They floated in 2004. Over the period from 2011 to 2018, they've scaled up the equipment by a factor of 100. So as Charles alluded to in the cost of batteries, similarly, the scale-up effect on the cost of the electrolyser that turns the water and renewable energy into hydrogen and oxygen has also gone up in scale and come down in price significantly. So that's really allowing us to do what we're doing here in Australia today with much more economic effectiveness. Last year, we were bought by Linde Gas, 20% investment, and set up a joint venture that now gives us much greater reach into technology, both on farm and in industry, in terms of fueling stations and also gas conversion equipment. So it really gives us the opportunity as a group to have an end-to-end solution. So we're talking about upstream production and downstream dispensing, so fuel dispensing equipment for hydrogen for trucks and tractors and buses. And I guess just summarising, the approach, I've sort of worked with Charles and his colleagues on a number of projects, both in industry and in agribusiness. The overall approach is transitioning to a circular economy where we're basically using waste outputs and turning them into something valuable as an input. So we're using that waste from the piggery, turning it into gas and also into a fertiliser, and basically then also renewing and reducing the cost of our energy going in behind the meter using PV, wind, as Charles said, biogas. But also because we're creating some waste products into biogas, having both biogas and renewable hydrogen on farm creates new opportunities around potential from downstream products as industrial feedstock, which we'll talk about, such as ammonia. So we call this ISD, Integrated Sustainable Design. That's really what Charles and the team are practicing. And I guess the nice thing about hydrogen as an energy vector, I think on the graph Charles showed that it's there for large-scale energy and large duration. So this is an energy source for days, weeks, and months. Batteries are very useful within a day. So that's generally the differentiation between hydrogen and batteries. We're using hydrogen as a storage medium over the longer term and at larger scale. But as we said, it can be used for making renewable power. We can turn that back into heat by burning it, or we can actually use an absorption chiller to create cooling, which is very important in the dairy industry, but also use it as a transport fuel in fuel cell electric vehicles, both large scale and small scale on farm. And finally, we can use the spare oxygen, potentially the gas coming out of the biodigester, and create NH3 ammonia. So there's all sorts of other opportunities to create new revenues on farm from hydrogen as a starting point. This slide just really shows some of the industries. Obviously in New South Wales, there's a lot of discussion at the moment around Port Kembla and how we look at green steel as a big play, and some announcements to be made around that. But also, as I said, the chemical industry as well. How do we actually decarbonise, some of the industries around ammonia and making fertilisers? So a lot of work going on in Australia and internationally, and using hydrogen as a renewable chemistry feedstock. The nice thing about all the farm projects I've been involved in with Charles and others is that we now have plenty of opportunities around solar. A good point was made earlier about not sort of having solar on sort of arable land, so we can certainly use wasteland, and certainly a lot of the projects I've looked at have been using flood zones where you've got the right sort of racking for the solar to withstand flood events. But also a whole heap of work being done by my university, QUT, and others around a new subject called Agri Voltaics. So finding things that are crops that actually grow underneath solar panels is pretty useful as well. So solar's a given. Wind power as well. I mean, we've got 10,000, 20,000 Southern Cross pumps around the place. So using good wind assets is also part of the solution on farm. And I think thirdly, Charles touched on the biogas side of things happening in piggeries and others. The fourth one there on the right-hand side, the organic Rankine cycle, or ORC. I'm building a hotel project in Hokkaido at the moment in Japan, and we're just using forest waste. So we're collecting the forest waste, the inorganic waste, the biomass, pelletizing, and using that to create electricity and hot water. So again, it's something that we've got plenty of in certain regions on farm for extra energy. Water obviously is a feedstock we need to make hydrogen, and I guess we don't want to end up like Americans using corn crops to make ethanol and having people going hungry. Pardon me. Similarly, we don't want to see the same thing in Australia. We need to make sure that the water we use for production of hydrogen is excess water from rainfall, excess groundwater, certainly recycled water coming out of local community sewage treatment plants. And also, if we're using fuel cells to convert that hydrogen back into electricity, one of the byproducts of that is heat and water. So again, we can close the loop, so to speak, on the water mass balance. So again, fuel cells are quite useful to give us water back to reuse. So again, we're moving to a closed loop system on water. In terms of mobility, this is a use case for hydrogen, both in the city and on farm. I think Charles touched on some of the work that's being done in sort of tractor sector. A transitional period we're seeing. I think one of the speakers today will talk about the transition through battery electric tractors through to fuel cell electric tractors as we go up in range. Our Kiwi friends over there on the right hand side, Uniquad, that's now available here in Australia. Also, motorbikes, but also more interesting for us in the States, my California office has a fuel cell pickup truck, so the first one to market with that in Australia wins. And then obviously, as I talked about earlier, the bigger trucks, that if a lot of our larger agribusiness clients have got their own trucks for logistics, certainly there'll be a range of 2 or 3 manufacturers in the market in the next year or so to make those available on farm as well. So mobility is certainly the high value use case for hydrogen produced on farm. But as I touched on earlier, we can actually use it as a replacement for LPG or fuel oil, simply for drying and heating crops. But we can also, over a period of time, create a far more cost-effective storage medium than a battery over a day. So if we want to store things during winter, we're using hydrogen. If we're storing something during the day, we can use batteries. And in both cases, for hydrogen, we can turn it back into electricity via a turbine or a fuel cell. As I said, in the case of the fuel cell, we get water back as well. Both those processes create heat as a byproduct. So again, we can use that for water heating, for washdown, or we can use it in absorption chillers that I think Charles touched on to create cool air for product cooling and storage. Third point is where we actually do have renewable hydrogen produced on farm and we have excess. I mean, one of the obvious byproducts, because we're splitting H2O into H2 and O2, we can look at new revenue opportunities for aquaculture. So we're doing a lot of work around Australia, Project Sea Dragon up in the Northern Territory, using waste oxygen for aquaculture. So again, creating a new revenue source on farm. But also Charles touched on some of the biofuels. So we can actually make renewable methane, but also dimethyl ether from biogas coming out of a biodigester combined with renewable hydrogen. So again, we can make a direct diesel fuel replacement as a stopgap measure until we have widespread availability of vehicles on farm. As I touched on, we have the aquaculture opportunity. So again, having renewable hydrogen on farm can actually co-combine with other chemicals such as CO2 from biogas create new opportunities and new revenues for the farm. So it's about diversity and sustainability. I guess one of the best examples I've seen, and again, credit to Charles and his team, that I was brought in 3 years ago to work with Charles and his team on a large-scale abattoir project in Queensland up around Gladstone. And basically, I was quite amazed to see the cost per head of processing beef at around $300 compared to our competitors in the US was around $150 equivalent, and some of our competitors in Asia underneath $100 a head. Obviously, they have the same quality, but using hydrogen to both run the plant but also the logistics cost has actually helped us get that down to around $200 a head. So basically, with our quality at that price point, we have a huge opportunity to improve our exports in processed beef. But at the same time, we're using that wastewater to create spare hydrogen for export to Japan and South Korea. So again, the abattoir is basically a renewable hydrogen production plant as well as a beef processing, and we're using that to create extra revenues for the facility. I guess in a nutshell, it's been fantastic seeing the availability of funds to help de-risk the exploration of hydrogen on farm from New South Wales DPI, and certainly Charles and some of the other project partners, PGS, have worked at some initial audits to really get an understanding of where the energy is being used on farm, both in stationary and motive applications, to start building up an idea of, okay, if I can start producing renewable hydrogen on farm, what's the return on investment and what sort of transition? And I think, again, fuel security has been flagged as an issue. So this is about the economics up front, but it's also about security of supply. So having cheap diesel is no good if our diesel supply lines are interrupted by, unfortunate military action in the North of Australia. So, I think everyone's press. We're not bolstering our military resources in the north for nothing. We're exposed from a fuel security viewpoint. So this is about sustainability as well as economics. And I guess once you've done a bit of a study with the DPI funding and doing a proper audit, you can start to assess, is hydrogen, is battery, biogas. You start to look at the options and start to look at a proper feed study. And then, as I said, there's plenty of money at the federal level as well to actually help offset the cost of the capital expenditure on the infrastructure. So I guess, look, we use a 4-stage process, and I think attending the webinar today, I think a lot of you already started on this process. If you haven't, certainly encourage you to reach out to Charles and Jock and the team to explore how you could get started on this pathway. So that's pretty much it for me. I hope it was useful. And as always, as Jock would tell you, I'd much rather answer some questions and try to help the process along that pathway than spend any more time. So thank you.
Thanks, Neil. That's, yes, nice sort of quick overview. We do have time for questions, so feel free to throw some in. But there was a question there about the efficiency of fuel cells, where that's at. Neil, is that sort of jump out at you an answer there?
Yeah, I mean, it's a good question. I mean, I guess I can certainly say that the efficiency of a fuel cell is about the same as the efficiency of a little bit better than a diesel engine. So from a pure energy economics viewpoint, we're getting around 50% efficiency out of the fuel cell compared to as a diesel engine. I think a lot of these cases, Jock, it's economic efficiency as well. So it's really my cost, my delivered cost of work, whether I'm delivering a kilowatt hour out of a generator or a kilometre out of a tractor. It's really, what the net cost is per kilometre or kilowatt hour is really the end game of the analysis.
Mm-hmm. Yep. And the other one I've just thought it'd be nice for you to ruminate on for a bit is the potential for redevelopment. Like as we come through the COVID era recovery, should we ever get there, which I'm hoping we will. How do you see, like in a theoretical world, what would the world look like for you if we went full hydrogen over the next, 5 years and just 5 to 10 years, went hard at it? What would be achievable?
Well, I think, good question and very timely. And again, I think as Charles alluded to earlier, Jock, that this whole COVID issue has only accelerated the process. I think to talk to anyone in the industry, we're actually busier now than we were pre-COVID. predominantly because of this fuel security issue. And I think it's really heightens people's awareness. So again, that's what prompted, I think, Transport for New South Wales to bring forward that bus program. We'd already done work in some of the bus depots in New South Wales around battery electric. They're now really bringing forward this whole hydrogen fuel cell electric program with the buses because of the diesel issue and reliability of supply. So basically, I think that's what we're going to see, this first evidence of, hydrogen deployment in cities around municipal transport. And that certainly then extends to the ferries and also the trains. So a lot of work being done in Sydney, particularly obviously on the harbour, but also around the trains. So I think that's where we'll see it go in terms of large-scale infrastructure projects in the city, in terms of public transport as the highest use case for the hydrogen. But certainly, in agribusiness and regional Australia, we've already had a large number of inquiries around how do local councils use their wastewater treatment plants to act as the sort of regional hub for hydrogen production. And a lot of this work, again, working with Csiro and Charles's teams, the nice thing about regional wastewater treatment plants, number one, it's wastewater, so it's not going anywhere else. We're not taking drinking water away from anyone. And number two, we've got generally large land areas around these wastewater treatment plants in regional Australia where we can actually use solar power behind the meters. So I think that's probably the first evidence we'll see post-COVID of some of these projects in regional Australia. Will be local councils certainly looking to use their wastewater assets and some of the funding being made available to them by both state and federal governments for post-COVID infrastructure development projects, and start using that to transition their own fleets in terms of buses and garbage trucks and council assets, but then making that relatively low-cost hydrogen fuel jock available to local agribusiness who may not have the ability on the farm to do their own solar or their own wind and hydrogen, but they can certainly buy in a tank of liquid or gaseous hydrogen stored on farm, just like LP, and start the transition process. So whilst they may not be making the hydrogen on farm, they'll certainly get it shipped in from a local council. So then they take off on that journey. So I think that's probably regional Australia. We'll start seeing some pretty clever councils start to transition their wastewater and create hydrogen for both their own needs and the local community.
We've got a couple of questions coming through on the chat, Neil. The first one is from Neil. How much water does it take to produce the equivalent of, say, 1,000 litres of diesel?
Yeah, I love that one. If you'd asked me that a year ago, Natasha, I couldn't have answered you off the cuff, but because of some of the wonderful ABC radio interviews that Jock made me do last year, I can tell you that it's about the same. So a litre of water generally will produce, so to do that question on 1,000 litres of diesel, 1,000 litres of water is what you need. So it's almost a 1-for-1, which is, I guess, an interesting fact.
And a related question is, how many kilowatts of solar is needed to make the equivalent of 1 litre of diesel energy? Yep,
okay. So again, taking that same line, so 1 kilo of hydrogen uses about 10 litres of water. So that's really giving you the same as 10 litres of diesel, as I said earlier. And we need around 45 kilowatt hours of electricity to make that 1 kilo of hydrogen. So really 45 kilowatt hours of electricity in roughly is giving you around that 10 litre equivalency of diesel. So it's not a water-centric challenge, Natasha, it's really an energy-centric. So it's where you get that 45 kilowatt hours of electricity from. And predominantly, we've got plenty of energy available, and certainly spill energy over certain times of the year, depending on the growing cycle, or cropping cycle, whatever business you're in. On farm, you can use that spare energy to make hydrogen during those downtimes.
And Scott asks, I recently heard a futurist answer a 100-year question for fuel on farm in the future. He said a farm will produce the fuel for his farm from the biomass left over and solar, so a closed loop. Any thoughts?
Yeah, well, that's why I put that diagram up, Natasha, that, yeah, it is all about being closed loop. And I guess we used to be that way. We used to be masters of our own destiny in agribusiness, but then, we've let others come in and sort of sell us on productivity and other things. But I think it's ironic. My 90-year-old mum was alive. We're just going back to where we used to be. So, yeah, closed loop, solar, waste products, convert that back to energy. And I threw one in at Wagga, I think, as well, about it always amazes me that we do nothing with the energy we have available during lightning storms. So there's another one to add to the list, what we do with all that energy in the sky. I'll leave you with that one.
And Jack asks, will all transport, for example cars, also likely to evolve into hydrogen power?
I think at that small end of town, Natasha, honestly, you know, I'm ex-Yuasa batteries, Century batteries, and no, I think around town, smaller cars, you know, to have an autonomous Uber, you know, Toyota Yaris running around town on a battery is where we go. It's when you get into the heavier transports, it's really the buses, the trucks, the ferries, the trains, that's really where. So no, we'll see battery electric around the cities, you know, for years. And I guess whether it's 50-50, 80-20, really, it's more battery at the smaller end of town in the city for a lightweight car, and it's more the, you know, the diesel is, as I said, the buses, trucks, trains, and ferries and tractors. So it's using both.
And Philip asks, can you comment on the safety aspects of hydrogen?
Well, that's an interesting one. Again, as an electrical engineer, having come into the market 6 years ago studying hydrogen, is that I didn't realise that there's trailers and trailers of hydrogen running up and down the Hume from Altona and Victoria up to the Boar Island and for the north in Queensland. Basically running, ironically, our coal-fired power stations up and down the east coast, they run off, are cooled, the turbines are cooled by hydrogen. So we've been running hydrogen around Australia for decades without incident, and the fact that no one knows that is the fact that it's safe. The issue that some of my gas engineering colleagues have pointed out is that hydrogen is the lightest gas. It goes up if there's a fracture in a storage vessel, whereas LP, natural gas and others are heavier than air and they pool around on the ground, and that's when accidents happen. So no, the safety case has been proven for decades.
Great, thanks. And Johnny asks, please correct me if I'm wrong. At 700 ATM pressure, a volume of hydrogen has 15% of diesel. Will a fuel tank need to be 6.5 times bigger?
That's a good one. Well, actually, it's interesting that Toyota used 700 bar in their fuel cell tanks for the cars and the buses, and shortly to announce on some of the bigger trucks using 700 bar. But a lot of the lower pressure vessels.
Oh, we've lost you, Neil. Are you still there? I've totally lost sound. I can still see your cursor moving around the screen. Do you want to jump in, Jock, so I can get Neil back on?
That's all right. We'll have to hunt Neil down. Look, if you can chase him down again, Tash, I'll just shoot him see if I can get him on the phone call side of things too. One thing that we are developing in the background to this sort of business is an energy demonstration trailer. So the idea is that we will be able to go around to field days over time, should we ever be able to go out in the public domain again. But when that happens, and we have field days and shows and things like that, our plan is to actually take a trailer mounted fuel cell hydrogen unit as a demonstration of this technology. There's a whole pile of things that can run off that even now, just from a basic fuel cell. But we're just going to do, the plan at this stage is to demonstrate it using hair cutting technology. So it's just we'll actually go to shows and we'll do some charity shaves, but that'll all be powered by a hydrogen fuel cell arrangement. Just as a demonstration, we'll also run a few pumps and, you know, the normal things you might do in an agricultural sense. But it's just to sort of show that the technology's there, it exists, the hydrogen's there, there is an opportunity to actually adopt this over time. And I guess as a fill-in guide, one of the thoughts I had while we're waiting for Neil to reconnect with the world is that over time, there's been similar groups of people sitting on similar groups of hills looking out over the horizon. And I'm pretty sure there was a group of people who rode horses to the top of the hill and sort of looked out and saw steam, and sort of some of them sort of went, oh, that steam engine will never work. And others sort of, you know, jumped into the idea that the steam could be the machine of the future, power of the future. And likewise, at the end of the steam age, I suspect there was a heap of people similar to what we're doing today, standing there looking out, going, steam might be dying. There's this internal combustion engine coming into the game. And I think we're sort of at the next sort of juncture of that, where we're sitting on top of the hill with internal combustion engines coming to the end of their game and looking at alternatives. And one of those is most likely the fuel cell technology. But, you know, all that has to play out over time, but the signs are pretty positive, I think. You want to throw anything in, Mike, while we're chasing the man who's missing? Oh, yeah, just you throw in a comment. I want to do an advertisement after you finish.
Yeah, no, so just as Jock's alluded to, we're going to call the trailer HCATs. We're going to partner with, the trailer concept is going to be called HCATs, and we're going to partner with probably the Hairdressing Association and a number of other players to try and take that to, I guess, just the general public, have a bit of fun with it. So that's where we're at the moment. Yep. Okay, Jock, thank you.
Right. Okay, so the other ad that I have to throw in just as a filler is that at the end of the day, there's going to be a survey monkey sort of option for everybody, just to give us a bit of feedback about what you thought about the day and what might be good to include in the next version of this sort of day. And what I'm going to do is I've made these little shirts up for the speakers, and they're just, you know, it's a Brewing Beyond Diesel, and on the back there's a nice little graphic that includes the all-important words saving the world. So, but one lucky participant in the survey will pick someone out at random. So if you get to the end of the day, they'll email out a Survey Monkey link to everybody who's been here today. If you fill that out, and once we get that feedback, then I'll pick somebody out of that group. So there's a chance to, you know, wear one of these. It's a bit like the hard chat. The limited edition big Save the World shirt is something that you can get your hands on by filling out an evaluation at the end of the day. Okay.
Thanks, John. I think we've got Neil back. Neil, are you there?
You back, Neil?
Sorry about that, guys. Yeah, so we were in the middle of it wasn't as if my hydrogen pressure tank exploded or anything like that. So apologies to the person who asked that question, but yeah, I was saying that the manufacturers use different pressures for different applications. So in the heavier transport space isn't an issue, so they're using 350 bar, but in the more compact stuff, they're using the 700, if that helped answer that last question.
Just, Neil, a quick moment about, do you see there being a hydrogen market sort of potential, or what's the potential do you see for farmers engaging in, you know, creating hydrogen from solar panels that are sitting around the place? Is that ever going to be a realistic thing, do you think, or how do you see that playing out?
I think it's pretty much horses for courses, Jock. So I think in some cases, yes, if you're in an area where you're blessed with lots of water and lots of solar, you know, you, I guess, play the role, as I suggested earlier, of that local council, that you might actually be the district's, you know, premier hydrogen producer. So yes, there is opportunities there for, just like we do with electrons on the electricity grid, that there's a market there. And I guess our partner via Linda BOC Australia already have, you know, trucks running around shipping hydrogen. So to pick up a load from a major agribusiness that, as I said, is blessed with lots of wastewater and solar, yes, there is a market. And similarly, you know, I guess if you've got other things, as Charles was talking about with the biogas, and you can make you know, other products like ammonia or dimethyl ether, you know, there's a chemical market as well. So there's a market for the raw product eventually, but also a market for value-added products. I guess it's like everything we talk about export. It's better that if you can value add. So I'd much rather see people trading in some of the tertiary products like ammonia and other things where you can actually use some other waste products off farm to create those products and get a higher return. So yeah, again, anything's up for grabs as long as you've got that raw energy input and wastewater feedstock. Yeah, it's there for commercial opportunity.
And Ashley asks, at what point does the hydrogen become viable? For example, what size energy bill would you need for the cost to be ROI in 7 to 8 years?
Yeah, okay, good question. And I think there's a really great that CSIRO roadmap, Natasha, that I sort of had on the slide earlier, it's got a really good chart in it that sort of shows that sort of thing. It shows you, same thing, it shows you at what price of hydrogen per kilo do I need to match an existing diesel application. So at off-grid power for diesel, it shows you X dollars per kilo. So from a scaling factor viewpoint, generally if we're looking at off-grid diesel, it's generally fairly cost comparative now to get those sort of ROIs, noting that we are using federal government subsidies to help with this. But as you start getting into direct grid competition, you really need to be in an application where you're using the heat or the cooling from the technology as well. So it's like a co-generation or tri-generation situation, if that makes sense. So particularly when we looked at some of the stuff on the Riverina with Jock last year, where we've got chillers and dairies, the economics are far superior if I'm actually using the heat and cooling as well as the electricity. So it really depends on getting an understanding of that. So scale isn't really the issue, it's more the application determines that cost effectiveness.
Thanks. And Lorenzo asks, how do you get trained in hydrogen technologies in Australia?
Well, I think that's a big subject that the federal government, particularly Dr. Finkel and COAG, have looked at. So there's a whole series of activities programmed at the federal government level, helping to fund state. So, for example, TAFE colleges taking our existing curriculum for gas fitters and just adding another module for hydrogen gas as they've done for going from natural gas to LP. So it's just another gas. So really, it's just an addendum to the existing curriculum for gas fitting. So there'll be courses available from our various technical colleges to upskill people into that hydrogen space.
And we have a comment from John who says, George Friedman's book, The Next 100 Years, forecasts satellite solar blankets collecting solar energy outside of our atmosphere and beaming the energy down in microwaves to floating collectors in the ocean that made hydrogen to pipe to mainland. Is this possible or fantasy?
Well, I guess I've been to a lot of conferences where they open up the conference, Natasha, about Jules Verne's comments in the 1800s about hydrogen energy being produced from water. So I think, anything's up for grabs. It's more a case of horses for courses. I mean, we're doing a huge wind project in the UK at the moment, a gigawatt of wind power, and it's got a cable going back to the shore, and we're making hydrogen on shore. So, if that's where we're heading, that's being constructed and designed now. So I think anything's up for grabs, and that's why I mentioned you might be getting some energy from the sky during a lightning storm to run the electrolyzer. Who knows? But I think we just have to take the blinkers off and look at all options and be self-sufficient as opposed to relying on international shipments of diesel.
Thanks. And Mike's just put a link into the chat box for some hydrogen training. And that's all of the questions in the chat box for now. Thanks.
Brilliant. Thank you.
Well, I've got one more, Neil, because I can't let you get away yet.
Thanks, Scott. I'm still here. I'm here for duration.
No, that's right. No, I was just thinking about economies of scale and the cost of fuel cells and stuff like that. Can you just ruminate on that for a moment? Is it starting to happen? Are they dropping significantly?
It's a bit like the batteries. Yes, the answer is yes. So I mean, they've halved in the last 10 years, and I guess it's like the same trajectory as solar panels and batteries drop. They're forecasting halving again in the next 5 years. So I think we typically see this with technology. But I think we had this discussion on one of the previous seminars that from my knowledge, the smallest fuel cells I've worked with are around say 60 kilowatts. So that's the sort of opening gambit. So it's not a lot of energy in terms of getting into the game, but it might actually be the case where you might have that 65 kilowatt fuel cell on farm, but basically you might be buying your hydrogen gas in from the local council or BOC. So it's more a case of the scale of use is smaller. In the scale of production, that's a lot bigger. And I guess the bigger you go in production, so ideally we want to see a hub and spoke model. You can go down to tens of kilowatts in the application, but we're really making hydrogen in the megawatts at centralised facilities around wastewater, if that helps.
All right. Are we looking, anybody got any more questions to pin Neil down with? We could You did mention that, like, there's always the safety question, Neil, that we, bump into, the old Hindenburg story. You just, I know that always presses buttons with you. But
You mean that airship where the paint caught fire? Yeah, I love talking about that one.
Yeah. I mean, it is one of the comments that people bring up every time you say hydrogen. There's sort of, that's the fear factor is interesting. How do you sort of rebut that or calm that down from how you said?
Well, I generally don't do it myself, Jock. I refer to my colleagues at Shell and BP, and this is, you can have a look at the ITM global website out of the UK. We started this process 10 years ago, converting Shell service stations to hydrogen. And you're right, in the early days, because of the H factor, basically the electrolysis and the storage of hydrogen was over on the side of the forecourt, typically where you'd see a car wash in our local service stations. Roll forward 10 years later, the hydrogen production and the hydrogen dispensing is actually on the forecourt. So, it's really shown that the safety case has moved on in 10 years in Shell's eyes, that they consider it so safe that the hydrogen bowser and dispensing is now on forecourt next to the diesel and next to the unleaded. The irony is that it's the DC electric fast chargers that are actually over on the side of the forecourt because they're too slow. So one of the things we're doing now is we're actually using the hydrogen in the Shell stations to create back into electricity using fuel cells to run the DC fast chargers for the electric vehicles. So I know Elon Musk would hate this, but it's the hydrogen that's creating the electricity for the electric vehicles. So again, I think it's the big brands like Shell and others that are really making those decisions on the safety case. So I really defer to their decision to move hydrogen from the sidelines to the main game on forecourt. So I guess that's the safety case in a nutshell. Have a look at the Shell website in the UK and see what they've done in terms of that safety issue.
All right. I'm just wondering whether we jump into the next session or whether we wait. We're due for a break. The idea was we'd just have questions and answers up towards for probably another 5 minutes or so. Has anybody got any comments or questions for Charles or for James or in general just before? And then we might, if there's not, we'll just have a slightly longer break, just 15 minutes. Because I haven't had breakfast yet, so I wouldn't mind a little bit of a break. But is there any other questions that people have at this stage?
I've got a question for James, who's still on. I'd be interested to know how can government help, I guess, to facilitate this transition to renewables and electrification of the fleet. He's mentioned a few things in his talk. I'm just interested from a government point of view. How does government help in this space?
It's a good question. I think a lot of the work that we've done has been around that microgrid thing. Essentially making sure that people have got actually access to, some of the electricity grid. And I think the problem is the grid design is designed for the old, coal-fired power stations where you've got a huge amount of generation sort of centrally located and you sort of spread it around, rather than what's going to happen now is that that energy generation is going to be disseminated seriously. Now, so I think there's some infrastructure issues, but there's also the issue of actually who gets access to the grid. There's, I think it's 10 kilowatt arrangement at the moment, into certain pieces of the grid. So to make these sort of bespoke on-farm electricity generation, hydrogen, whatever, to make these viable, you're going to actually have the option of pouring stuff into the grid when you got too much, or when the price is right, because we've got pricing arrangements that don't shape use at the moment. We've got grid connectivity stuff that's not fit for purpose, and cockies can't sort of get a set of pliers and key into it. So there's a few pieces of work that I think could make these more viable. And, you know, the speakers that have been speaking about, you know, the viability of these arrangements, they've got to be sort of mixed. You know, the technologies have got to be mixed, and, you know, the markets have got to be mixed. You've got to use it for yourself. You've got to export ammonia, you know, whatever. You know, to make that work, I think you do actually have to have some, be able to connect. It's connecting into the grid, and it's having a grid that's fit for purpose, you know, for connecting into. That's the essence of the microgrid argument. Anyhow, I'm not an expert on it.
Thanks, Wayne.
Okay. There's just one last question there, Tash, if you want to throw that in. That's a bit of an interesting one, but.
Sure. Ashley says, we have a crematorium with an energy bill of 70K per annum. Would it be viable for solar and water to hydrogen gas to use in the gas burners?
Oh, I might have accidentally muted Neil. Sorry, Neil.
Can you hear me, Jock?
Yep, I can.
Yep.
Sorry, I just hit the mute button on you.
Yeah, well, I mean, it's an interesting question. Yeah, I guess the answer is yes. I mean, I'd probably throw it to Charles as well. That you know, generally, as if it's just in a simple situation, you know, for sort of combustion of the gas, you'd probably use biogas first before you'd use hydrogen. But yeah, you could end up doing a blend. I guess it really just depends what gas sources and what water and solar sources you've got around the crematorium to see what's the you know, the transport impost as well to get it there. But yeah, and the answer is yes. You're just basically burning a gas. So yeah, I guess you could use it.
Mm-hmm. Okay. Okay. So we're all calm. What we might do is just have a 10-minute break. 10 or 15, well, let's go for 15. We'll come back at 5 to 3, if that's okay. That'll give us time to boil the jug, make a sandwich and things like that. So if there's no more questions, we're just due for a quick break. I need to have a stretch too. I would imagine everybody else is in the same boat. So I'll see you all back here in at 5 to. Okay.